Hey everyone. Every time you click a link, stream a show, or send a message, you're tapping into this incredible, invisible set of rules that makes our entire digital world possible. Today, we're going to pull back the curtain and trace that blueprint, step by step, to see how data actually flies across the globe in seconds.
Okay, so think about this for a second. You're chilling at home, you open an app on your phone, but the server that holds all that data might be thousands of miles away on a completely different continent. How in the world does it load in like a split second? That feeling of instant connection, well, it's not magic. It's actually an incredible piece of engineering. You see, it all comes down to solving one huge problem. It's like this. Imagine I call someone up, but they speak a totally different language than I do. We're connected, right? They can physically hear the sounds I'm making through the phone. But can they understand me? Not a chance. See, just being connected isn't enough. You got to speak the same language.
And that, right there, is the key. For two computers to have a real conversation, they need to agree on a set of rules beforehand. In the tech world, we call these rules protocols. They're the shared language that makes sure what one computer sends is exactly what the other one understands. It's all about making sure everyone's on the same page.
So you might be wondering, how do you get billions of devices, computers, phones, servers, you name it, made by thousands of different companies to all agree on the same rules? Well, that's where this universal rulebook comes in. It's a framework called the OSI Model, and it's the blueprint that brings order to the chaos of network communication.
The OSI model, that stands for Open Systems Interconnection, was actually dreamt up way back in 1974. And the genius of this model is how it takes this ridiculously complex process. We're talking over 70 different things that have to happen, like error checking, encryption, and finding the right address, and it breaks it all down into 7 neat, manageable layers. Each layer has one very specific job to do.
And here they are, the famous 7 layers. So when you send something, your data travels down the stack, from top to bottom. It's like an assembly line where each layer adds its own special wrapper. And then, on the other side, the process is perfectly reversed. The data goes up the stack, and each layer unwraps the package until the original message is revealed. Pretty cool, right?
Okay, before we dive into the full journey, I gotta call out one layer specifically. Layer 4, the transport layer. People call it the heart of OSI, and for good reason. This layer is basically the quality control manager for the entire trip. Its whole job is to make sure your message gets there in one piece and in the right order. Super, super important. All right, you ready? Let's follow a single piece of data on its wild ride down through these layers as it gets all packaged up for its big trip across the internet.
And it all kicks off with something you probably do 100 times a day. Let's say you open up your browser and decide to check Facebook. That one little click, yeah, that's what starts this whole chain reaction.
So the journey begins up here in what we call the software layers, layers 7, 6, and 5. Layer 7, application, that's your browser, the part you actually interact with. Layer 6, presentation, is like a universal translator. It gets the data into the right format and handles stuff like encryption. And Layer 5, session, is the one that opens the door for communication and keeps that connection open while you're talking.
Okay, so at this point, your request to see your news feed is just, well, it's just data. That's the technical term for it. It's the raw information before it gets all packaged up.
And now we hit that all-important layer, the heart of the operation, the transport layer. Looks at that big chunk of data and says, whoa, that's too big to send all at once. So it chops it up into smaller pieces, kind of like pages in a book. And here's the brilliant part. It numbers every single piece. Why? So the computer on the other end can put it all back together in the right order, even if the pieces arrive all jumbled up.
So once our data has been chopped up and numbered by the transport layer, it gets a new name. It's not just data anymore. Each little piece is now called a segment.
All right, on to layer 3, the network layer. I want you to think of this layer as the global postal service for the internet. Its job is to take each one of those segments and slop a shipping label on it. And on that label, the source and destination IP addresses. That's the global address for your computer and the Facebook server. This layer figures out the best route across the entire world to get it there.
And just like that, our segment gets another layer. Now that it has the global address on it, it gets a new name. We call it a packet. It's basically a sealed envelope ready to be mailed.
Okay, so if Layer 3 was the global postal service, think of Layer 2, the data link layer, as your friendly neighborhood mail carrier. This layer doesn't care about the final destination in another country. Nope, it only cares about getting the packet to the very next stop, which is probably your home router. It adds the local physical addresses, the MAC addresses, to get it there.
So our packet gets wrapped up one more time for this local trip. And this fully prepped, locally addressed little bundle is now called a frame. We're almost ready to go.
And here we are, at the very bottom, Layer 1, the physical layer. This is where all that digital information becomes, well, physical. It takes that frame and turns it into electrical signals for a copper wire, flashes of light for a fiber optic cable, or radio waves for Wi-Fi. This is the delivery truck hitting the road.
And this is what it all boils down to. That simple desire to see your friends' photos is now just a stream of ones and zeros ready to blast across the network at pretty much the speed of light. Absolutely incredible.
Okay, so zoom. Those bits fly across the globe and hit the Facebook server. So what now? Well, the whole thing just happens in reverse. It's time to unwrap the present.
It really is like opening one of those Russian nesting dolls. First, the physical layer grabs those ones and zeros and turns them back into a frame. Then, the data link layer looks at it, says, yep, this is for me, strips off its wrapper, and passes the packet inside up to the next layer. The network layer does the same thing, checks the IP address, unwraps it, and passes the segment up. And finally, our hero, the transport layer, gathers up all those numbered segments, puts them back in the right order like a puzzle, and hands the original, complete piece of data to the Facebook application.
And get this, that entire process, all the chopping, wrapping, addressing, sending, and then all the unwrapping and reassembling, it happens in the blink of an eye. It's this beautiful, invisible system that just works.
And that amazing journey from your idea to bits and all the way back again is the silent engine behind everything we do online. Loading a web page, sending an email, streaming a movie, it all relies on this. The whole point of this incredibly complex system is to do something beautifully simple. Make two computers, even if they're on opposite sides of the planet, feel like they're sitting right next to each other having a conversation. It's the framework that creates the seamless magic we take for granted every single day.
So there you have it, the invisible blueprint of our digital world. But here's a thought to leave you with. The OSI model is a concept born in the 1970s. It's brilliant, but it was designed for a world that looks very different from ours today. So as our world gets filled with AI, with billions of smart devices, with things we can't even imagine yet, it really makes you wonder, doesn't it? What will the universal rulebook for tomorrow's internet look like?